I should open my micro maybe. Hi everyone, welcome to the stream. Yeah. Today I'm going to obviously show you a bit of Yahaha Studio. Especially the node graphing. So for a first thing, how to set up the whole Visual Studio Code thing. Yeah. There's a good explanation on how to set up Visual Studio Code and the Yahaha Lua debugger. And I will not go over this because the Yahaha official website explains this in really good, and I don't want to mess this up by trying to deinstall and then reinstall my stuff. So yeah, just follow the instructions on the API reference how to start coding. Yeah, I did this, and if I can do this, everyone can do this. So yeah, this works really good. What I want to show you is basically what you do once you have set this up. Yeah, so we are in a completely new scene, very empty, nothing here. I just chose the base template with just the flat surface, not the flat surface, but the flat terrain template. And we have the starting point, we have a single directional light, and that's about it. And yeah, I will go from here. So first things first, we need basically any kind of object, really, to add a node graph to it. I'm gonna start with something very simple. Okay, I should maybe give the terrain a different color, since we can't really see the block on it. Okay, that's better. So we have our block. Here it is. And yeah, I'm going to build a very simple node graph with this, that just to show you how node graphing, or what it actually does, how it works. Before we go into details on specific node graphs and on specific details, what you can do. Yeah, but basically we're going to build the basic first as an example, and then we're going on. So step one, let's say we want to trigger this block via node graph. So for example, we're putting a move component on it, and now as soon as the game starts, the block will go up. Yeah, this is nothing special. This is how Yahaha is set up. And yeah, we can emulate this. We can emulate tricks like this with the node graph, which I want to show you. So first off, I'm going to okay, so what I'm going to do first is set up a node graph that moves this cube, just so we have a comparison of what happens with the component and what happens in the node graph, basically. I use this as a reference, so the idea is the same. We want this object to move 5 units upwards as soon as the player joins. Let's test this once. Yeah, we join, and about 5 seconds after the game starts, the block moves up, and currently that's about it. Okay. Step 1. What you're going to need is a move component on the object. So whenever you want to trigger a component, move or revolve or rotate or anything via a node graph, you need to have the gameplay component on the object, but you should, in the best way, disable the component. So right now, if I start the game, I'm looking for my block, and nothing happens. Ta-da! Okay, so step one, how do I actually put a node graph on anything? Down in the Components tab, you can also click the little arrow. This one here. And if you do, you have a little pop-up menu that says Add Community Component, Add Lua Script, and Add a Node Graph. What pops up is a another bar where you can either search for node graphs if you like have a lot of them and you want to edit one specific one, or you can add a new node graph, which then prompts you to enter a name. Let's say simple move. Important is you can't put spaces in the name, so make this as simple as you can. Done. So what happens if you have a new space open the first time? The first time this happens, you basically get Visual Studio Code open, and it's not in the node graph option. This is because right now, when we work with node graphs or any kind of script, the PC doesn't, or usually your PC doesn't want you to edit those, because they could, in theory, hypothetically, change stuff in your PC, and you don't want that. So, what we're going to do is we're going to tell Visual Studio Code that we are okay with this. Step one. We're going to open the folder. This is the address where the folder is, and you open this folder, and Visual Studio Code will ask you, are you trusting the files in this folder? We say yes, because this is fine. And now we can click back to our node graph. And we get the overlay of the workbench work thing for the node graphs, which looks like a really big Excel sheet, which is a good thing. Excel is awesome. What you have is a few things. We have our an explorer here in the corner, which lists all the stuff we have in our space. Now here's one thing. What this lists, what the Explorer lists, is all assets placed in the space. You can't access the player over this. You can't access items from Yahaha over this unless you placed those items, which we will do, in the actual world. So if you just have an item that drops somewhere, but you don't have it placed somewhere, it doesn't work. You need to have the asset placed in the world to see it in the Explorer and to access it. Okay. The second thing we have, let me get blue, is variables. This one here. Variables are basically placeholders or containers for stuff. Basically, you can have a variable like is something on or off. You can have a variable for a specific value that you generated somehow, and other stuff. But this is basically a container or a placeholder that will keep track of this for this one node graph. So what you can't do is basically have a node graph with a variable and then transfer to another node graph. This doesn't work. You either have it in one node graph or you have to build another node graph with new variables. This issue is interesting if you copy paste stuff from one node graph to another. If you basically have 2 times the same node graph, and in this case you would need to set up the variables again for the second node graph. Okay. Lastly, we have the add node button, which does exactly what we would expect. You can add a node, and this is what we're going to check out next. So we have 1, 2, 3, 4, 5 different node options here, and the 6th, which is variable, which is empty because we don't have any variable set up. If we ever set up a variable because we need one, it would theoretically pop up under here, so we get another triangle we can open. Okay. Let's start with something very, very simple with the different node options we have. Property is okay. Let me grab the red one. So property, first one, gives you. We're going to start this again. First, we start with an event. An event is some kind of trigger. So whenever we use a trigger in the studio, for example, on start means on the start of the game. On enter means when you enter the trigger box. On global dialog complete means whenever there is a dialogue somewhere in the world completed, and a specific one when you touch the player, when you as a player or any other player actually touches it, then it does something. So basically this is the initiating moment for whatever component you set up. This is the event. Yeah, the event starts your chain of events, your node graph. Secondly, we have the function. The function is basically whatever you have here: the start position, the stay time, the the move speed, the relative position you want the object to go in, the looping mode, more or less. So every variable you can change here: the point of the start position, the stay time, the move speed, whatever. Yeah, this is what you can change with a function, or what a function would do. These are all functions, but these are visually easier than Nodegraph. Yet maybe we come to the point where they aren't. But yeah, the function is basically to tell the app to do something specific. Okay, and lastly, or third, property. Property is a specific value. So for example, you have a line in a bad example. Property gives you a specific value you ask for. If you don't use a function for this, if you don't use a, you can basically just. Basically, this gives you an information. Property is the information that is in the game that you can ask for, more or less. Then we have math. Math is exactly that. Math is the work of logic and operators. So and, or, and, not, or. Operators are the same, just for different kinds of functions. Basically, float is something I have to do with coordinates. Integer are something to whenever you have an integer. Yeah, and stuff like that. So basically, whenever you want a specific math problem, when you want to compare two things with each other, or when you want to when you compare something is greater as equal, whenever you need to do something like that, you go into the math section, and we have the process control, which is basically a decision. These are decisions, and we will mostly use branch and maybe while. But yeah, I mostly use branches because branches is basically the if-when clause that you can basically do to branch, obviously, your decision or your node tree. Okay, so far so catastrophic. So we need an event. In this case, the event in the we used was when the game starts, which is whenever the player enters the game. And we have a lot of different components here. We have a damage component, which gives you two events. Damaged event, whenever an entity in this world is damaged. We have zero HP event, whenever an entity in this world is set to 0 HP by damage, by whatever. Physics API is anything with if you hit it, if you enter a trigger, if you exit a trigger, if you touch it. Back component is basically when something is added to a backpack or removed from a backpack, or the number on it changes. So you get one more of something. Character API is basically everything to do with the player character, more or less. So when it is pushed, when it falls, when it touches the ground, enter and exit trigger again, when the player dies, when the player swims or stops swimming. Game is player joined and player left event. In this case, we want the player joint event. We want the player joint event? We have player joined and player left events. So player joins and player leaves. We have the game teleport API, which triggers apparently only when the teleport fails to do so. We have the group component. You can trigger stuff whenever something sends a group invite, or when the group changes. We have the input API, which means we can trigger stuff on a specific key that is pressed. We have the mover component, which is interesting because the mover component is actually the move component we have set up here. This thing is the mover component. So basically we can say, hey, something starts to move. Let's start another chain. Let's start something completely different whenever this object moves, or stops moving, or finishes moving. Okay. Pendulum is the what's it called? The revolve function, as far as I know. Spinner is the rotate function. Player component is the player spawned event, which I have played around with, but I'm not entirely sure what it does yet. Tracer movement is currently not usable. Just keep that in mind. This is something that is worked on, so we will get to that at some point. Okay. So we start this one with player joint event. Player joins. Now I need really any node right now to show you something. to explain how stuff works, or how the node works. We're going to check out the nodes. This is longer than it needs to be. Okay. So, step 1. We have different colors for the different things. There. Okay. So, we have events. Events always have this little arrow in the corner, and you don't have anything beneath that arrow on this side, so basically nothing can lead to this event. This event is triggered, and when it is triggered, it starts a chain. So when I talk about chains, I mean the following things. You have an outgoing on the right side on every node, more or less. You have some outgoing points. You have this arrowy one, which if you click and drag it, you get this white line, and you can see that the end, which I have on my mouse right now, also has a white arrow. And when I just stop using it, you can see that it automatically, so whenever I pull this and I just let go, you see that it opens the add node thing with all connected nodes available that we can use. So basically we can use a property node here, we can use a function node here, and we can use a process control node here. We can't use another event because you can't chain into events. And we don't have math. And we don't have variables because we don't have any variables set up yet, so it doesn't find anything. Or it doesn't find anything. Okay. Secondly, we have also for many of these nodes you have a hover over. So when you hover over it with your mouse, you also get a small pop-up which tells you what actually happens. So fired when a player has joined the game. This is actually what we want. And you have this node here, which is labeled V0. If we hover over it, we don't get a pop-up. And this also adds to math, because we also can do math stuff with this. This is basically an integer value that we get from V0, which we don't need right now, but we could, for example, try to manipulate something with an integer we get whenever a player joins. Okay. Again, event, no entry, because it starts whenever something happens, whenever an event is fired. The outgoing white line is the line that the node graph will work with. So basically it hops from the starting event, white line, to the next whatever, executes whatever it is connected to, then jumps to the next thing connected to the white line. You have only one white line you can follow. You can have multiple white lines, but it only follows one strand of white line. And if it has multiple options to follow, it will give you an error. Okay. We have functions. Functions have the following interesting things. They have this f in front, so you basically know, okay, this is a function, it does something. In this case, it says get move speed. So it checks the move speed of an entity that is not yet specified, but get means it asks for the current move speed. It checks it. There's also set, which basically gives you the option to put in a value. You have the incoming white line, which means you can chain this. You can chain into this, and you can also put an entity into this. You can say, hey, I want to link the entity that I want to into this. You have a bar where you can check for all your assets spawned. You can basically just click on it, and then it links then it shows you all the assets in the space. And self. You have self here, and you have self here in this list, and you can also type self if you want. Self always means that the node graph, or the function, or whatever you have, the function, the event, whatever, is referring to the object it is on. Self means what asset, what object am I on, and it refers to this one. So if you ever set up a node graph on something, self is the first option, always the first option in the list, so it's very easy to set up. You have an outgoing white line, so you can chain from this as well. So into, execute, out of, and you have a result, which is blue, which means this node graph will give us a float value out. Basically, we get a number. We get a number that can have digits after the comma. Basically, you have an integer which is a full number, 1, 2, 3, 4, 5, whatever. And you have a float which can be 1.03 or 2.41, or you can have 0.12, whatever. But blue means it is a number with potentially numbers digits after the comma, and the more greenish one has a full value, 1, 2, 3, 4, has to be a full number. And green means it asks for an asset. Green usually means it asks for an asset. Sorry, I know this is kind of an info dump. Lastly, we have properties for now, which have this neat little I for information. So we know, okay, this gives me information, and currently it gives me no information because it doesn't have anything it refers to. We will only use a few of those anyway, but we will use those. Okay. So we have our player joined event and we want to move, so we know this node graph starts whenever whenever a player joins. Step 2, we want the movable component. Give me a second. Okay. We have a... Okay, again, sorry. This event, whatever this node graph, whatever it is, fires whenever a player joins. Step 1, we want the object this is on to move, so we need the event, the function. And now we have a lot of functions, and I'm not going to explain every one because I don't know all of those. What we're going to look for is the Yamover component. And this has a few simple notes. Start means the movement that is set up starts. Stop means the movement that was set up stops. Set move speed means we are setting the move speed. Okay, let's check out this node. We can chain into this. We know it does something. It asks for an entity. It asks for the entity that will have a move speed, which is itself. It wants a specific value for the move speed, which is an float, which means it can be any value between 0 and I don't know if there's a max value. In this case, move speed would be 5, which we can set here. So we're going to set this to 5 as well. Yeah. If you hover over this, you actually set the move speed in parentheses meters per second. Okay. So what we just did now is basically we set up that this has a move speed of 5. And next we are going to set up the fact. So this object waits for 5 seconds before it starts moving. So we need this object to wait 5 seconds as well, which we will do. And now I'm going to show you another cool thing. If you already know which node you want to use, because in this example I know I want to use the delay function, I can just type in delay in the search, and it will reduce the number of nodes to all nodes that have this part in their name. In this case, it's a function, utility function delay. Clickety. So another function, and it's going to wait for 5 seconds. Actually no. Actually, we're going to need this later, and this is another cool feature. You can just pull this out, click somewhere, and it's gone, and you have no connection anymore. You can also pull this from the other side, and yeah, we're going to store this because we need it later. What we're going to need next is the relative position. We're going to set up the relative position. How are we going to do this? There's a few different options for this. Function, mover component, set target position. Okay. How do I set the target position? I can do two things. I can grab this object, move it up to where I want it, copy paste all these position values and hope that it works, which is not what I'm going to do. I could basically just say, okay, 1.8 and epsilon was 100, 200, 295, and Z was minus 17.6, and hope that this actually works. Chances are it's not. Okay, so what we have here is a red input, and red means this function asks me for a coordinate. So red is coordinates, and I'm going to show you this really quick. You have a few different options for this. You have this violet point, which is a boolean. Boolean can be either 1 or 0. Boolean is either on or off. Yeah, yes or no. You have a float, which is, as I told you, a number which can have digits after the comma. You can have float 3, which is some kind of coordinate. By the way, if I use this coordinate, it will let me set all 3 values. I can have an integer, which is always a full number, so I can't type 1.5, for example. And I can have a string, which I haven't used yet. But a string can also be a sentence. Actually, I have used these, never mind. Yeah, but these are the different type of variables, and these are also the different types of inputs you can have. Except for the green one, which you can't use a variable for, because green always asks you for a asset. Okay, so how do we get the target position? And this is something that I started doing quite recently. This is for any kind of movement where you have a specific movement or where you want to move something to a specific point. I go on about this. So we're going to disconnect this actually, and we are going to check position, and we're going to write it correctly. So we have a few properties. Yeah, 3D sound position data doesn't sound like we want to use it. Yeah, query result isn't interesting. So we have a few functions. We can set a position. Okay, sounds nice. We can reset position and rotation. This sounds also nice, but not what we want. What we want is in the movable component again, or movable component, not the mover component. Movable component means any kind of component that I can potentially move, so every asset. And what we want is, there's two different things. There is position and there's global position. Now here's the difference. Right now I have a position. Up here I have a position for this object. And this is the global position, which is nice. But if, for example, I adding this object, a sphere, and I slave the cube to the sphere, it actually reset the position, as you can see. This is not the same position I had, because the position is the relative position of this object that I currently have selected in relation to its parent and to anything else. And this can be tricky and a problem. So if you use get position, you can screw this up if you have it in some kind of weird new numbers in the position. So what we are going to do is we are going to try to type correctly. I'm not drunk, I promise. We're going to get global position, because global position always asks for the global position of the object. And as you can see, I'm asking for get, because get just checks which entity, myself, and it basically says, okay, this is the entity. What is the current global position? What is the value for this for X, Y, and Z? And then it gives me that. So basically, second thing is, hey, after the move speed is set, please check the global position of this object right now. And if I just plug this in, it would basically say, hey, the position you want to move in is the same position we have, and we don't want that, so we need to add something to the value. So, function float3, because float3 is the red stuff. We're going to add. Yeah. And now you have two different values. You have the float3, which is the position we are starting from. And we have value, which we add 5 to. I think this one, but it can be mixed up, I'm not sure. And we are going to link this, and the result of this is basically whatever we put in plus y5 is the position we want this object to go into. Okay. Next, we have so what we have set up is currently, the move speed, and the relative point, and nothing else. And we're almost done actually, because we are going to say, hey, yeah, mover component, start, myself, add a delay of 5 seconds, and that's it, basically. So let's go, let's rubber duck this and go over this one time. The chain starts when the player... The move speed of the object the node graph is on is set to 5. The position of the object this is on is checked. The coordinates of the position are increased by y is 5, so by 5y units. The new position this is going to go into is defined by the previously changed position. The movement is starting and it's delaying for 5 seconds. We're saving this, we're compiling this. Always save first. You're saving, basically you're saving the set of the node graph, and then you compile what you saved last. So basically save, compile. Okay. Let's see what happens. It should theoretically go up. If I didn't mess anything up, we'll see. It goes up, it just doesn't delay. Okay. So I guess we will actually unplug the delay, unplug the start, and just switch out these nodes. Save. Compile. We do this, we do save and compile because we need to basically update or actualize the current node graph. Okay, there it is. Look good. And that's basically it. And now we're getting a bit more complex. Okay. Let's go for one thing that was a topic in the last few days. Someone mentioned the moving doors, the sliding doors that you wanted, and I'm going to write a node graph for this that will open the door when you come close and close the door when you're through it. And we're going to set this up so that you can't reopen the door. Hopefully, this is the goal. So the next goal is build a sliding door. It opens when you go up to it. It closes behind you. Let's see. We need a door setup. Give me a cube. Thank you. Okay, we have a corridor. Step 2, we need a door. I like this one. Yeah, this is good. Actually, let's use this one. Okay. Okay, so we have our door. And the goal is that when we walk up to it, it opens. It slides to the side. And if we are going through it, it closes. Okay. How do we do this? How would we do this without a node? So, we would, for example, use the move component, obviously. we wanted it to move. We wanted it to move. We wanted it to move to minus x point minus 2.35x, and we wanted it to move two ways. Yeah. Stay time of 1 second, so it basically has a 1 second delay before it enters, and it has a 3 second delay before it closes again, and a move speed of 5 is okay. And we want this to either on touch, but if I touch it again, I would move again, so we probably want to set this up with an enter, which means we need a trigger box. Okay, let's grab our trigger box. Trigger box, thank you. Going to pull this out a bit. Going to move this back a bit. Okay. This is a basic setup. Okay, let's check this out. If this works. So far, so good. Okay. So we basically set it up with ease with the current nodes. Now we're going to set up the same thing. Setup stays the same, but with nodes. Just to reiterate what we just learned. And yes, I'm going to go to other things besides moving. I just want to reiterate on how the nodes work before we go into something more complex. Okay. We are going to need a new node graph, which is door slide. Done. Okay, and we can actually do a little fun thing here, which I want to show you actually. So, event. Because right now the door slides open and it is on a timer, and this is it. We have the timer. We can do a little bit more with node graphs. So step 1 is we have an event, which is on trigger enter. Yeah, we enter a trigger box. Event, no input, because this triggers whenever we enter a certain trigger. Now we need to set two things. We need to set the trigger, and we need to set the entity that enters said trigger. So step 1, we set up the trigger. And in this case, we are going to go into the property nodes. What we need is the entity. We need to get the entity ID. So basically, this is a property that asks, hey, I have an entity ID, which is a solid number. And so basically what this node does is it asks for, hey, which unique number is set to an entity, and it gives me this this number. And what I linked up is basically said, hey, if the number you give me is the same number as whatever is triggered. So this node, this starting node, triggers anytime, whenever any kind of trigger box is entered. And we don't want the door to go open every time a trigger is entered. We only want it to go on when the trigger of the door is entered. So we need to check if the entity ID of whatever is triggered is the same as the door. We're going to do this with a simple trick. We're going to right click on the get entity ID, and we're going to duplicate this one. Now we have two times the same thing, and the upper one doesn't have an input in the input, so we have an empty box. which we fill with self. We can also, for example, say, hey, I want to use this door. Yeah, so basically we have 2 times entity ID. This entity ID will give me the unique number of the door. This entity ID will give me the unique number of whatever trigger was just entered. And I want this to be the same. So what I'm going to do is, I'm going into math, into the operator, saying this has to be equal. So we have a trigger that is entered. Any trigger whatsoever on this map. The first thing that happens is it gives me the ID of whatever is entered. It gives me the ID of the door. And it checks, is this the same? If yes, if it is. And I just said if, so we're going to need a branch. If this condition is true, if the entity ID of whatever is triggered and the door entity is true, if both are correct, if both are the same number, then we're going further. We are going to go to a mover component. We're going to set the move speed of the object this is on because it's on the door. Going to set this to 5 again. We're going to add a delay of 1 second. We are going to get the global position of this. We're going to add a float 3, which in this case we can copy. And by the way, this doesn't work. Why? Simple. The add function only makes the value bigger. So if I have minus 2.35, it adds 2.35. It doesn't add minus 2.35. So this doesn't work. This is important. What we want to do is we want a function of float 3, which is called subtract. We're going to copy this. We're going to enter it here. We're going to delete this one. So now it basically gets the global position of the door. It subtracts 2.03 units of the on the x value. And then we're going to start the mover component of itself. No, actually not. Before we do that, we actually need a target position, which is the resulting position. Yeah, so nothing new. And now we can start. So far, so good. Right? Yeah, we don't really have an entity that runs into this, so let's check what happens. Let's just check out what happens. Yeah, in theory this should do nothing or work. Let's see. So it doesn't. Okay, actually it does anything, but interestingly it subtracts on the wrong scale. Interesting. Okay. So if I leave the entity open, basically checks if any entity, is it a player, is it a non-player? It doesn't matter. It doesn't matter if it's a player or non-player. Whatever enters the trigger box will start this trigger because I don't have defined anything for the triggering entity. Okay. I think we need to do this in the y-axis. This is basically because this is mixed up currently, but this is, I think, already known to the developers. Okay. This is also not the right. Wait, no. Save, compile. Interesting. This is very interesting. Okay, for further purposes, let's try something else. I mean, it moves in the other direction, but this isn't really important if it moves left or right. As long as it works. This is really interesting, and I don't have a quick fix for this. Which means we may have to go the hard way. Yep, we do. Okay. Let's trick this. Let me show you something else. Okay. So we don't get the position from this. Actually. Okay. So we need a different way to approach this position. Step 1 is we can move the door and copy paste all the necessary necessary coordinates. Ooh. In theory this works. Let's see. Nope. I'm a bit stumped. Okay. Let's do this. We are going to get the global position of this door. And what I did just now is the following. In the Explorer I have a list of all the assets I added. And I just basically put this door over here. And what I'm going to do now is I can just pull this out of the Explorer. And what I get is basically an info and a property with this asset, and I can plug this, as you can see, into the entity. So I can basically just pull out the door that I'm going to move, plug this into all the entities that I want, and in this case it always refers to it. Basically always, whenever it checks the entity, always checks this asset, which is the same as self in this case. Okay, let's see if this works or if this doesn't work. Very curious. Well, okay, close enough. Okay, So what happens now is we enter the trigger. It checks if it is the door trigger. If it is the door trigger, it gives a movement speed, a delay, a global position, a target position, and it starts the movement. And specifically this movement. It starts specifically the movement of this door with a speed of 5 after 1 second to the position of the second door. And that's it. That's all it does. And if I enter any trigger that is not the door, it does nothing, because if it's not false, then it doesn't have an output. So basically it ends here in the branch. Okay. What I'm going to do now is the following. I'm going to check the global position of this door before it moves. Yeah, this is the original position. And now we're going to do something very fun. Now we are going to add a second event. In this case, we are going with the on trigger exit. So basically when we exit the trigger. And now we can do the following nice thing. I basically want the same setup. I want the entity ID. I want the triggers equal. I want the branch. I basically want the whole same thing. So I can just drag my mouse over everything. Duplicate this. Pull this back here. And I have now basically 2 node graphs. So what I'm going to check is... what I'm going to remove is the global positions. What I'm going to do is I'm grabbing the global position from the first node graph. Okay, and because I like wiggly lines, I'm going to move all this. But basically I'm grabbing the global position of the door before it moves. I'm plugging this into the second graph, which is on this on the second event chain, which is on the same node graph. I'm just going to plug this in here and this in here, so it looks the same. And now let's see what we build. So when I leave the trigger, which is the trigger on the door, and only if I leave the trigger on the door, then the move speed is set to 5. There is a delay of 1 second. Let's make this 0 seconds. There is a target position, which is the position of the door before it moves. And then start this movement. Let's check if this works. In theory, the door should move back as soon as we exit the trigger. Okay, door moves, we leave, and nothing happens. This sucks. Oh, right, because obviously, what did we do wrong? It checked the global position when we leave of the current position. Yay! What are we going to do about this? Well, glad you asked. Let's use a variable. Because, as I said earlier, the variable is a storage container. So we're going to call this original position. And we're going to set this, which is a function. So we're going to plug this in here. And this basically sets the original... Wait, no, this doesn't work either. Well, we can do this very simple. Actually, it should. Actually, this should work. Let's see if it works. So basically, this sets the original position once. So we enter the trigger. It checks if it's the right trigger. If it is, it sets a move speed, a delay, a global position. It checks the global position of the door. It stores this in this variable. It gets the global position of the second door. It moves the object to the position of the second door, and that's it. And let's see if I can. If I plug this in here, it should grab. So what it does, it grabs whatever I saved here and plugs it in. So it shouldn't, in theory, it shouldn't check again when exiting, but it should copy whatever we set up here. It basically should store the coordinates and start it again with the coordinates. So let's see if this works. Okay, this is very interesting. Okay, so no. Actually, we don't even need the global position in this case. Okay, so what we're going to do is we are going to put in oops. We are going to simply add an empty object. Call it door backslide. Leave it exactly where it is. Grab this object. Duplicate the get global position, obviously. And plug this all in here. And this does not have a collider. This doesn't have a trigger box, which is fine enough. But yeah, sometimes you have to just troubleshoot. Oh, haha. The door has a trigger box. The trigger box of this door is really big. And obviously, whenever any entity, which also can be an asset, is entering this trigger, it fires. Also, whenever an object exits, which would be the other thing, it fires. This can't work. So we're going to need to make sure that only a player can start this chain of events, right? Let's do this. This is why we need the function, character array is player character. This basically checks, is this a player character? Going to have another branch. Actually, we don't need a branch for this. We can just do this first. Use a logic AND from math. And now we have the following setup. If the trigger box that is entered is the trigger box of the door, and the entity that is a player character, only if both things are true, we get a node graph, right? Yeah, same. Also, only when the player exits the thing, it starts. And now it should be fine. So, player runs up. Door slides open. Player leaves. Right. Player leaves, nothing happens. Interesting. You shouldn't forget to plug in all your node graphs. All your nodes. Okay. Third time's the charm. Or sixth time, I'm not sure. Okay. So far so good. We walk through and the door's closed. And we can't enter this again. Oh, we're trapped. Okay, so if I... Right. I enter. Slides open. I leave and it slides back. I enter. Slides open. I leave. It slides back. I enter. Slides open. I leave and no, I'm trapped again. Okay. So obviously I need to make sure that this part of the node graph is not accessible on the rebound. So I need to make this room closed up so I can't run into the backside. But yeah. Okay. Time for them other fun stuff. Someone asked me about weapons. So we're going to go look into the weapons thing. And then we are going to do something fun that I showed off, but not in a video. We're going to give the weapon an ability. Which starts whenever we hit something that's not us. So step 1, we need something to hit. This is not how you write knight. Okay, this is our nice knight. Nice knight is a bad monster. Let's call him Dr. Knight. Haha, I'm so crazy. Okay, 1 life, 1 attack, no defense. He doesn't have to attack. He resurrects every 10 seconds, which is every 5 seconds. Okay. So we have something we can hit. Actually, let's give him a bit more life. Let's give him 100 life. Let's give the player 1 attack is fine. Resource box, models. Let's use the bat. So, quick info. We have different kinds. We have the behavior melee weapon, which adds damage, which adds 9 damage. We have the interact UI, which basically just means that 3 meters around this object, we can touch it. And, or 2 meters around, we can touch it. And then it uses the tool component, which does the following. If you play on mobile, it will give you the sword logo in the corner where you have the punch usually. It is handled so it follows the right hand bone. It has a position set up. It is droppable, which means if you press G or the correct button on the phone, it drops the bat on the ground. It has a lot of input stuff set up, like if you hit the attack, then it does the one-handed attack animation, and so forth. Basically, I need 10 hits to pummel our dear Dr. Knight. 1, 2, 3, 4, looks good, 5, 6, 7, 8, 9, good night. Yeah, this is mean, but I know. Okay, so far so good. Now let's do some fun stuff. So, we can just add a node graph to this as well. New node graph, the bat power. Any ideas? Okay. So we need to start with an event. Let's see. This can't be damaged. This can... This can touch the other thing, hello? Where's my pop-up? Fired when the character enters another character or rigid body. Okay, so basically when they touch, we start. V0 is obviously one of the entities and V2 is the other entity, so let's think that V0 is the bat. So we need the entity ID again. No, this is the wrong entity ID. Property, yeah, entity ID. This is basically a setup you need every time, so yeah. So if the entity of the bat is the same as whatever enters or is entered, then it fires. First step, we don't want to start. Okay. Okay. Now we don't want this to happen when it's the player character. So what we're going to do is, if the bat enters anything, hits anything, and this is a player character. I'm sorry, I'm not really, yeah, I'm typing too fast. And the second is a player, then, so, step one, an entity touches another entity. Step 2, is the entity the bat? If yes, is the second thing a player? If yes, nothing happens. If false, if the entity that touches the thing is not a player, let's go on. The obvious thing is apply damage. Yeah. The target object is whatever I just hit. The entity that applies the damage is obviously the bat, and the amount of damage is obviously 10. So basically what happens is very simple. The bat hits any, touches anything, collides with anything. It's definitely the bat. It's definitely not a player. Deal damage. So now we just should, in theory, Wait. I'm not sure if I did this, so I'm just going to do this again. Let's see. Okay, so the bat has a box collider now, which should be helpful. Or not. Okay. Let's see where we did, okay. So, step 1. Maybe V1 and V2 are wrong. So I'm going to switch those up. So V1 is the entity and the entity that is the enemy, and the other one is the player character and the apply damage. Let's see if this is the problem. Nope. Okay. And now the fun starts, basically. What I'm going to show you next is what I learned to do to find the problem in my node graph. So obviously there's a problem in my node graph. Something isn't working. Yeah, let's check again. An object collides with another object. Is one of the objects the bat? Yes. Yeah, if yes, is the second object a player character? If no, apply damage to the secondary object. Yeah. By the way, you can also leave enemy empty and it doesn't do anything, so let's do this for now. Maybe this was it. I don't think so, but just for the funsies. No. Okay. What we're going to do now is we are going to use the print utility, which does the following. It prints a value that I say it should print to the this is a bad idea. This so what print does is a function, and it prints a value that I can choose. I can choose any value here, really. To the console. So let's open up the console. So far so good. Let's check in our node graph again. Okay, let's say we put this behind the first branch. Sounds fair. So it basically checks is the bat colliding with anything? If yes, give me a 1. Let's see if the bat actually has a collision. No, the bat doesn't have a collision. Okay. Step 2. Let's switch this up again. Let's see if it works now. No. Okay. Interesting. So the bat obviously doesn't have a collision. Okay. Now we learned something new. Let's do a different weapon. Because I actually got weapons to work. In this case, I currently got the throwing weapons to work. So I can also talk about the throwing weapon. So throwing weapons are set up by 3 different parts. You have the you have a throwing weapon which has a component that I have in my hand. It has a component that is spawned, which is the second boss. So whenever I throw something, it spawns, and we have a VF X effect, which is spawned whenever the object despawns. So basically, whenever my object despawns, I get the VH X effect. Okay. Yeah. All these have behavior spawnable objects. If you want to know about spawning, I have a video about it on the channel, so just check for Yahaha and spawnable objects on the channel and you will find a tutorial on how to spawn different stuff and how the behavior spawnable component works. Okay. And we have a spawned object again, which is the object that is this is thrown object. This is basically the thrown object. What we're going to do is we're going to add the bed power node graph to this one. Okay, increases damage by 9. Okay, let's actually not activate the node graph right now. So in theory, yeah, this deals about 10 damage. 1 damage from the player plus 9 damage from the 9 damage from the weapon. So yeah, now I'm going to activate the bed power, which adds another 10 damage. Okay. Maybe I used another event. Was it on hit? Nope. Okay. Yeah, this. So we actually get this to work. Even though I'm not getting it to work right now. I actually got this to work. I just would need to open another space. You know what? Let's check it out. Let's save this for now. Let's close this one as well, and we are going to go in the weapon testing facility. Okay, let's see how to set this up. Yeah, so this is another thrown weapon that I put the US on. Let's check how I did this. Haha, I totally did this to show you something. If you open your node graph, if you restart your app and you want to work on the node graph, it opens in the in this one line, whatever this is, and this is not really how we want to work. So how to fix this? Right click on the teleport node graph name, reopen editor with, and then you can choose the text editor, which is the active on default, or you can choose the active node graph editor. You can also configure default editor for node graph and click on the node graph editor. In this case, it opens the node graph by default with this one. I just reset this to show you this. So if you ever open a space the first time, and it shows you the one line, the text editor, right click on the node graph, reopen editor with, and then you can configure the default editor for node graphs. You can say the Yahaha node graph editor, and then it opens it in the node graph again. Okay, so I used on contact enter. Check the ID self. Player character no. And after a lot of stuff, I actually applied the damage. Basically the same setup, right? Okay. And now if you've reset the default node graph editor, at least if I didn't do anything wrong. It should open it in the node graph. No. Boo. Right click, reopen editor with. And here we are. Definitely the same. Interesting. Does it even print the 1? This is interesting. Let's check this. No, it doesn't. Okay, so yeah, you can actually mess around with the weapons. For example, the other node graph that I just showed you teleports the target around at more or less random. Yeah. So we've checked out a few node graphs. I showed you how to set this up. I showed you how to link node graphs. Let's actually go over nodes now. Because one thing that is really that is kind of intimidating is the sheer number of nodes you have. And let's start with all the events. So from the top event, damaging component. You have a component that fires whenever an entity that you specify is damaged. Yeah. You have the entity that is damaged, and you can pull out V0, which is the damaged entity itself. So basically this is, hey, I'm getting damaged, what should I do? You have the 0 HP event, which fires whenever an entity is 0 HP'd. By the way, if you want to, you can put all node graphs in one space into one giant node graph and just put them all over the place so you can single them out. I usually do a node graph for every specific thing that I want to do, but you can totally have multiple node graphs in the same node graph in case you for some reason need this, which can make things interesting and difficult. But yeah, since you have the get entity stuff, you can just say, hey, I have a second node graph, but it triggers on another a contact that is made or another trigger that is entered. So yeah, you can pool everything into one big node graph if you want to. Okay, 0 HP event. The specified entity is 0 HP'd. Physics API. Fired when the entity has been hit. Fires when the entity has been hit by a character, which gives us the entity that has been hit, which gives us a direction from the comms, 0 from the side. Yeah, so basically you get an output of did the hit come from left or right? Did it come from the top? Did it come from the downside? And you basically get the actual coordinates for where did this connect. The first one additionally has a collider. The entity that has been entered, the entity that was hit. Okay, maybe let's just, for the joke of it, let's do this one. Now I'm curious. Really curious. Nope. But we get an error message. On hit enter. So he doesn't like on hit enter. Okay. Fair enough. Okay. Actually, we wanted to go through the events. You have on hit exit. Fires when the entity stops being hit by the character. Okay. On trigger enter. Yeah, we already know this. If any entity enters a trigger. This also works if a trigger is entered from a non-player character. So if you remember the Mr. Smith mentioned from Vevro, the on trigger enter was used there in conjunction with the is not a player character combination. For the skull, you had to roll into a pit. So this is what was used there. Just FYI. Yeah. Also, when the trigger box is exited, on contact enter and on contact exit, which fires when another character exits another character or rigid body. Okay. And yeah, we have the on contact enter here. So yeah. What else do we have? Backpack component. Yeah. Fires when the backpack's data changed. So it doesn't matter if something is removed. It doesn't matter if something is added. Yeah, it doesn't matter if something just gets more. Whenever the data is changed, this event would fire. Yeah. This fires whenever an item is added. So whenever a stack is increased by 1 or whenever a new stack is added, this fires. Yeah, but we need to specify which entity we want this to be on. And we also have the same thing for whenever an item is removed from the inventory. So whenever you basically throw something away, or a Nodegraph removes something from your inventory, then this event is fired as well. We have the character API, which is push event. So whenever a character is pushed by something, we have a push direction, we have a push distance, so we can use all of these for any manipulation we want if we build the Nodegraph for this. Yeah, on fall, the character loses contact to the ground and falls. We can start this. character touches the ground. The character, so on enter trigger is basically the same. On exit trigger on died. Yeah, whenever something dies, this starts. We have on start swim and on end swim. So whenever a player or an entity starts the swimming animation, or in the second case, whenever a character ends the swimming animation. So whenever a character is hit. I know this is getting full, I'm sorry. Now we already had this. Never mind. Yeah, on push, on fall, on ground, and enter trigger and exit trigger are double, because we also can put up a float value from these. The game, a player joins or player leaves. We can also have a node graph that says when a player leaves. Fires when a player has disconnected from the game. In this event, you can get the left player by call Yagame get player ID, but the left player will not appear in Yagame get players. So you can call up which player left, but you can't get the player because it's not there. So whenever you try to basically use the get player entity or a get player property, then it will not return a value because there isn't a player to find. But as it says, we can get the player ID. Yeah. For the group player info, we can check which player actually left the game. On teleport failed. So whenever you try to change between spaces and it doesn't work, you get an event, which can be useful but is very narrow. You can manipulate stuff with the groups. So when you have set up groups and the groups change, you can use that. Group changed. And the third one is the same. Almost. Yeah, they can change when the group change or when the global number of group changes, basically. So you can have multiple groups because people can open up their own groups. You have the input IPA, which yeah, listen for keyboard key press events on an avatar entity or entity equipped on avatar entity. So basically this checks, hey, what does the player do? What key does the player presses, and if the right key is pressed, then you can fire an event. You can basically have this to a specific key, or you can have this whenever a key is pressed. So you can have an event whenever. Okay, this is getting full again. I'm up. So you can basically start something whenever something is moving. For example, let's take our door. Now, when the door is moving, we get another chain of events. Let's say, can we get the sound thingy? This is not the sound thingy that I wanted. But yeah, you can basically You can start with sound, you can start a chain reaction where one thing moves, the next thing moves, or you can spawn something, again check the other video, etc. So you have multiple options for this. Whatever you want to try and want to do. Yeah. You have the start event. Trigger when movement starts. Trigger when the movement starts. This is basically the same. Yeah, we have when the movement stops or pauses. For example, when you have a delay. Yeah, when the event is done. So basically, when the node graph is at the end. You have the same for the rotate and for the revolve component and for the rotate component. You have the Yahaha player component, which checks when the player avatar spawns. Yeah, this is different to when a player enters, actually, because the player avatar and the player are two different things, because you can change your player avatar out of the game currently, yeah, in the app. But yeah, this basically gives you the player ID, so basically which number does the player have, if it's first, second, third, whatever player. Each player has a unique ID. It gives you the spawn point. So basically, you can manipulate the spawn point that you use to manipulate this point. You can move it. You can respawn it, despawn it, change it. And the third one is, I think, the avatar entity. This is the avatar, the actual. This is important because the backpack, the inventory you have, is related to your avatar and not to the player. So this is so when you want to manipulate the inventory of a player, you need the avatar entity. And this is something I will show you. Spinner and tracer, which is currently not working. Okay. Let's check out the functions that we currently have. We have backpack item change. We have character entity, which checks what happens with the character. Okay. I think this would take a little bit too much time. Inventory. Let's play around with the inventory. Let's say we want to add an item to the player's inventory whenever something special happens. So let's say whenever this door moves, each time the door moves, we put a token into the player's inventory. We need something to put in the inventory, so we need an item. We're setting up the item. Okay, this item has the ID of 1. We will need this later. What we will also need is to place. Actually, no. Actually, we don't. Ha! We do not. Okay, so let's grab our door. Let's grab our door slide. Let's go somewhere where we have space. Okay. Event. Yeah, mover components. Start moving. So whenever the door starts moving, which is 2 times. 1 time when we enter and 1 time when we leave. Whenever this is moving, we start. function get player entity. So what this is wait. Actually, we need to set this up way up here. So, every time a player enters or exits the door, he gets a coin. How do we do that? We use the start moving component. And we need to check for the avatar. Yeah, we need to get the avatar entity. Now we're going to check from the avatar entity of of these. So basically the entity that ended the trigger gets is checked, and we get the avatar of the ID of that person. And now this is interesting. We have backpack item change, and we have the backpack component, which we want, and we're going to add something to it. So how is this set up? We have the entity, which is the player or whatever that so the first one, the entity, is the entity of the player. But if you use the entity of the player doesn't have an inventory, the avatar does. So we need to plug in the avatar. Item ID. Again, yeah, this is the integer number that this item has. So basically, whenever you make a new item, it gets a new ID. If you delete an item, for example, let me add this bracelet. This has the number 2. If I delete this and add a new item, let's say I add boat, you see that the ID is now 3, because the scene doesn't actually forget which item you made. It doesn't get deleted. It just gives in a new ID. It can't overwrite the ID that it already has. In this case, we want to add a coin, and we want to add 1 coin. By the way, this is also an integer number. You can't add a like you can't add 1.5 coins for example. Okay. So far so good. Let's check this out. It's rather simple in its setup. Okay. Let's see if this works. Nope. So I guess we need... I guess I have the wrong here, actually. I think this one. Get player entity. Nope. Okay, actually, you know what? This is the perfect time to use print. Let's see if this actually fires or not. Okay. This is very interesting. As we can see, this number is just rising. So this fires all the time. But it just starts moving once, in theory. Okay. At least it starts firing. So it should, in theory, drop us a lot of coins. Educated guess, we're not going to get an output. Yeah. Yeah, as you can see, this is yeah, not an exact science yet, at least for me. Yeah. And I know this all seems a bit scary and a bit complex, because you can see that, like, yeah, I'm also still looking into stuff. I'm still playing around with stuff. I'm still trying to check out or to find out how things work. And yeah. The whole thing is, yeah, but still, it's really interesting. It's a lot of fun to actually play around with this, build complex or interesting node graphs, and use a lot of features that you actually can't do in the engine itself. Yeah, I didn't really get much info on what to show. I mean, I tried to play around with the weapons, but I didn't really get anywhere with that this time. I definitely got to recheck what I did on the other side. So instead, let me show you a few other node graphs that I built that I can show you that might be of interest. So for example, one of my latest spaces was the fishing paradise. And yeah, this one has a lot of node graph that I can show you. So yeah, each of these so I don't know if you've tried it yet. Each of these bridges here has is set up by 2 or 3 of these wood pieces. It has an empty box, and it has a trigger box which is called fishing pool. And we will look into this fishing pool because it has a node graph. Actually, each of these has 2 node graphs, but we only need 1. Yeah, and this looks really complex, so let's go through what this does. So, we start with an on-trigger enter. We already know this, right? Nothing complex. We also have the entity and integer equal thing. So, we have a trigger box, which we see here. and each of the peers has one. It checks if this is if the trigger box of this specific peer is activated. If yes, it checks if a player character is entering in this trigger, and only if it doesn't, it goes further. And here we have the use for two variables, which are two float variables. We have a variable that is called fish, and I used this function here, which, as you can see, doesn't need an input. This function does something that it doesn't need to be started. It doesn't need to be in the chain of events. It can function without any prior or further. It is an independent function. What it does is each tick of the game, it generates a random number which is between 0 and 1. In this case. You can also add a lot of other values. What else? You have a delay, which is between 1 and 2 seconds, basically. So the input is between 1 and 2 at random, and the delay is set in seconds. Which is then used for the delay. So I basically have a fish variable and a delay variable. I wasn't sure if I could plug this in or if this would just mix up the delay. Yeah, and I get the global position from the little box on the end of the pier, which I will use later on. What is happening next is it checks if the value of the random fishing value is lower than 0.25. So basically all of these chains are identical to the first one. The only difference is the value that is checked. Let's start again. An object enters a trigger. The trigger entered is the trigger box under the pier, and the triggering object, the entering object is not a player. If that is the case, if an object that is not the player enters the trigger box under this specific pier, he pulls up a random value between 1 and 0, between 0 and 1. He pulls up a random value between 1 and 2. The value between 1 and 2 is used as a delay. The value... So then he pulls up the global position of the little box on the end of the pier. And then he checks the value between 0 and 1 that I first pulled up. If the value has a certain... so if the random number I have is a certain value, under 0.25, under 0.5, under whatever, he spawns an object on a position. He sets a rotation axis, rotation speed, and an angle, and he starts rotating this object, which in this case doesn't stop rotating because he rotates it on the angle. Then he rotates it on the same angle until I set a specific stop timer, which I do not have. So it rotates 360 degrees and 5 seconds per rotation. Yeah, and it doesn't get more complex than this. All it does is it checks how big is the value, and depending on the value, it spawns different things. It spawns the fish. It spawns some random garbage that you can find but not use. It spawns a coin, which is currently also not really useful. It can spawn the paper item, which is the instruction for the crafting, and it displays and it spawns an object that is called Snowy. which is part of the crafting of this space. Yeah, but that's basically it. Yeah, this is basically all that is to this space here. Again, each of these bridges has their own node graph. Yeah. They all look the same. The difference is what they spawn. Difference is really just in the name of the spawns. Yeah, and that's it. But to demonstrate this, I like this. Okay, this is a little bit loud. Okay. What also happens is, as you can see, there is no fishing rod here, but I just pulled one up because I have this rod spawn, which also has a node graph. So what we also can do, and as you can see, this is much simpler. I used the player joined event in the start to get the position of this rod spawn empty object here. This is this block. Yeah, it doesn't have a collision. You can just walk through it. I just needed this for the position. And he spawns an object that is called rod. He then rotates this again. So this is basically just the rotation of the rod whenever it comes up. Yeah. And that's basically all that is to this space. Yeah, so with 2 node graphs, one of which is copy-pasted 9 times because it's actually nothing more than just 9 times the copy-paste. Yeah, I've set up this space. I wanted to actually do a bit more, but currently the node graphs do not give me the option to play around with a bit more, but in the future I will probably have this option. So what else is possible? I can show you a lot of stuff in my most used space in the testing realm, where I basically just test a lot of stuff. Oh, it's a little sneak peek for next month. Nobody should have seen that. Yeah, what's here? There's the door you need 2 people for. There is the skull, the aforementioned. Even the balance thingy is basically set up with node. Nah, it's not set up with node graphs. It's actually just set up with spawn boxes and stuff. We have a node graph here, which is rather simple. We have the same start again. Yeah, we're checking if the enter trigger is the trigger box of this here object. We check if it's a player character, and if both are true, then we check the global position of this object. We add a bit of a y-axis, so this is a bit above the ground, and we spawn something that is called night, and we set its max hit points to 100. Basically this, when I play this, yeah, it spawns the night, and it spawns on top of the whole thing. And you can see that each time I run into here, I drop it, I spawn another night. So yeah, this is one thing you can do with Nodegraphs currently. Another fun thing that I set up quite recently is this one here, where I tested out what happens if you teleport in and out of trigger boxes. I think I have a trigger box on this door as well, but yeah. So actually, if you have a lot of trigger boxes, it starts to look at some point your no, this was not what I wanted. At some point your list starts looking like this. Yeah, and I don't even know what most of these do anymore. For example, another node graph that I set up that I can show you is this one, which is called clear switch, and it's also rather short. I have another trigger box. Yeah, it checks if it is the trigger box itself. It checks if it's a player character, and if anything but a player character enters the trigger box, it gets 1000 damage on the head, which in the action looks something like this. We have this NPC set. The NPC has a behavior path. He walks up and down these spaces, and he ends up in the trigger box apparently. And what basically happens is sudden death for the princess. Yeah. But yeah, you can do a lot of fun stuff with these node graphs. Okay, I think actually that's it for today. If you have questions, leave them in the comments. If you have ideas, what you want to see, leave them in the comments, and I will try to figure it out and make a video about it. I know this was a lot of info dumping, especially in the end with all the special node graphs. I just wanted to emphasize that you can do a lot of stuff with these node graphs if you get creative enough, that you can't do with the current components. So node graphing is basically using the components to their maximum capacity, to the maximum potential they have. Yeah, there's a lot of nodes, or not. By the way, you can't edit the node graph if you are testing your game. So if something doesn't work or something is weird, just check if you are actually still testing. Yeah, there's a lot of nodes. I didn't go over all of this. I basically just showed you the events, because showing you all the functions is way too much and probably way too intimidating. But yeah, hit me up if you have questions, and I will try to figure out if and how this works. Yeah. And I hope I could inspire you to actually try out how the node graph works, play around with this, just see what you can break and what you can make. And that's it for today. Thanks for watching, and I hope I see you guys around.